Hello, good morning. My name is Yusuf Hassan and I am from Nigeria. I am particularly interested in joining this fellowship because I want to gain real life experience in artificial intelligence and machine learning. I have taken some courses on data science and machine learning, and I'm currently learning computer vision and deep learning from World Quant University through their course Deep Learning for Computer Vision. Before this time, I have taken a machine learning intern position with Summit Africa, and through this fellowship, I hope that if I'm accepted, which I pray so, I would learn more about artificial intelligence in a practical sense. This is my presentation for the challenge even. So for the challenge, I took on the computer vision part, which is creating a model or a flower classification model using ResNet-50. So the heading is flower classification using ResNet-50 transfer learning. This project focuses on building an image classification model using deep learning to accurately identify different types of flowers from images. Leveraging on Oxford's 102 category flower dataset, which contains 8,189 images across 102 flower species commonly found in the UK. The model is trained using a pre-trained deep learning method, which is the ResNet-50 architecture from the PyTorch library. The project involves loading and preprocessing datasets, fine-tuning the ResNet-50 model for multi-class classification, and evaluating its performance using standard metrics. The goal is to demonstrate the effectiveness of transfer learning in solving complex visual recognition problems with relatively limited labeled data. The first thing I did was installing and importing the necessary packages for this project. I installed the SciPy and the TQDM package, and I imported the OS library, the tar file, because the data were originally given in the tar file format, so which I imported to be able to extract them. The scipy.io for loading the MATLAB data, the NumPy, the PIL library, and the QTDM, the Torch, and the sklearn. So these are basically the libraries that I imported for this project because they are necessary for the execution of this project. Secondly, I loaded and extracted the dataset. So using Colab, I use Colab particularly for this project. I downloaded the files and I uploaded them on Colab. So from here, I opened them from the Colab and extracted the whole of the images from the tar file. Now, the third step was that I loaded the labels and splitted the dataset. So the labels and the data splits are stored in the MATLAB files. So I loaded them using the scipy.io library. So this is the code for that particular task. Then I created a custom dataset. So I created a custom dataset using the PyTorch data loader, so which is indicated in the code below. Then I transformed. Then later I preprocessed the dataset and I resized them and I normalized them. So I resized them to 224 by 224 and I normalized them using the image net, min, and std. Then I loaded the pre-trained model. As I said before, the pre-trained model specified for this particular task was the ResNet-50. It's a deep learning pre-trained model used for carrying out some computer vision tasks. I loaded them, and this is the practical code for the loading of the model. Then for the optimizer and loss, I use the cross entropy loss and the Adam optimizer. So this is the code for the practical for this is the code for that particular task. Then I trained a few epochs tracking the loss and validation. So in the eighth task of executing this project, I did the training and the validation of this particular model. So I trained on few epochs, tracking the training loss and the validation accuracy. Then later I trained the model. As we say, after 10 epoch, so we have a loss of 0.02, and the initial loss that we had at the beginning was about 4.1. We see that there is a drastic improvement in the model, and the initial accuracy for the model was 54, and after the final epoch training we had an accuracy of 89% for the validation set. So after this, I evaluated on the test set, and after that we had an accuracy of 88% on the test set. So having an accuracy of 89% on the validation and an accuracy of 88% on the test set is actually a good start for this model. This shows that the model is performing well, but rather there is still need for improvement. There's still need for improvement, and there's room for that. Increasing the number of epochs and training it longer, and also the optimizing our data will actually open room for a higher accuracy for this project. Thank you very much. This is my humble presentation. I'm indeed grateful to be granted this opportunity, and I hope that I will be considered for this fellowship. Thank you very much.